Containerized data centers, the future of modular AI infrastructure. Executive summary: containerized data centers adopt a modular design, similar to small modular reactors, to create small distributed AI infrastructure. These factory-built units house specialized computing power, optimized for rapid inference tasks rather than large-scale training. Strategically placed near existing power and fiber grids, CDCS dramatically reduce data latency and ensure better resource utilization. This decentralized approach supports the future of AI, which prioritizes private, user-loaded data and localized security, potentially challenging the dominance of current hyperscale data center operators. Article: The modern world runs on massive amounts of data. Data centers serve as the central nervous system for all digital activity. These facilities house vast collections of computers and servers. They have grown into colossal buildings over the last few decades. Now, new ideas propose a significant change to this centralized model. We can draw a powerful parallel from the energy industry. That sector is currently embracing small modular reactors, or SMRs. These SMRs offer a different approach to generating power. They are factory-assembled units, and they can be installed wherever they are needed. We should apply the same modular principles to data centers. This shift would create smaller, flexible, and distributed computing units across the country. This new approach offers benefits in speed, efficiency, and data privacy. It promises to redefine how artificial intelligence operates in our communities. The concept of modularity. A containerized data center is a complete self-contained computing facility. Operators build the unit inside a standard shipping container. This container holds all necessary components for data processing. It includes servers, storage, networking gear, and cooling systems. This is a huge contrast to traditional data centers. The massive sites are built from the ground up on expensive real estate. They require enormous construction projects. Conversely, manufacturers can quickly assemble CDCS in a factory. They then ship these units to any desired location. This modular design makes deployment much faster. It also drastically reduces overall construction costs. The containers are easily expandable. Operators simply link more units together as computing needs increase. These portable facilities represent a significant leap forward in infrastructure design. Decentralization and the power grid. Existing large data centers often cluster in specific, advantageous locations. They favor areas with cheap electricity and abundant fiber optic connectivity. This centralization creates bottlenecks and reliance on a few key spots. However, smaller data centers could easily avoid these problems. I recently had Gemini generate a map that showed the electric grid overlaid with the fiber optic grid. This map revealed many locations suitable for smaller data center construction. Local power substations offer immediate energy access. Nearby fiber lines offer high-speed network connections. CDCS can take advantage of these existing resources. They can be placed directly where the power and fiber already meet. This strategic placement offers two major advantages. First, it reduces the overall load on the main grid. Second, it shortens the physical distance between the data and the user. The reduction in distance results in lower latency. Lower latency gives the user quicker, more responsive AI services. This distributed model makes far better use of national infrastructure, optimizing for inference. These smaller CDCS would not handle every computing job. Massive, complex AI models require immense computing power for training. This initial training process will likely remain centralized for now. However, these modular units are perfectly suited for inference. Inference is the process where a trained AI model runs and delivers a result. The end user asks the model a question. The model uses its existing knowledge to give an answer. This specific task requires less raw power than the training process. Companies like Grok specialize in high-speed inference. They build hardware specifically for rapid AI calculations. A CDC could easily house 1,000 to 10,000 specialized inference cards. These dedicated facilities could deliver rapid results for utility companies. They would run large enough models for many common purposes. This localized capacity ensures speedy and reliable service for everyone. The rise of private and local AI. The most valuable applications of AI involve private data. Users want models loaded with their personal, proprietary information. This data might include medical records, financial histories, or company reports. Users absolutely need security and privacy for this sensitive content. Centralized hyperscale models pose significant risks to private data. Thousands of containerized data centers solve this problem effectively. They can be loaded with private user-selected data. This model keeps sensitive information off the public cloud. People worldwide would greatly benefit from this approach. Programs like GPT-4 already make local model deployment possible. A CDC could house a personalized AI assistant for a local business. The data never leaves the premises. This ensures maximum security and compliance. Decentralized AI makes the technology far more trustworthy for individuals and companies. The shifting landscape of hyperscalers. A few enormous data center operators currently dominate the industry. We call these companies hyperscalers. They build multi-acre complexes to offer every kind of digital service. Many people assume this massive scale is the only path forward for AI. We must seriously question the true need for these everything data centers. The reality is we only need a few large centers for initial model training and deep research. Most daily computing needs are better served locally. The trend toward distributed computing may threaten the current giants. Some of the existing hyperscalers could face serious challenges soon. They invest billions in centralized real estate. The market may shift towards small, targeted infrastructure. The future favors providers who can offer rapid, local, and private AI capabilities. The age of the monolithic data center may soon pass. Conclusion. The modular data center concept provides clear advantages. It mirrors the innovative approach of small modular reactors in the energy sector. Containerized data centers offer flexibility and rapid deployment. They reduce latency by sitting closer to the user. Most importantly, they increase privacy for personal and sensitive data. This decentralized infrastructure makes AI more accessible and reliable. The change will fundamentally reshape the landscape of artificial intelligence.